Last class, we looked at the diazonium ion as a way to incorporate new groups onto the aromatic ring. So now what we're going to do is pick back up with synthesis and incorporate in the utility of that diazonium ion into our synthetic sequence. So the best way to do this is by looking at a few examples. So let's say that we want to take benzene, and then through some series of reactions, we want to prepare this tetra-substituted benzene. Okay, well what you want to do is develop some sort of a strategy. And first you should notice that we have this fluorine on the ring. And the fluorine, that can only be added through the diazonium ion. So we've only talked about fluorination via diazonium ion in the class. Okay, then also in relationship to this top position where the fluorine is at, right here, also in relation to where the fluorine is at here, we need 3 bromine groups, 2 at the ortho positions and 1 at the para position. Well, we know if we have a very strongly activating group like OH or NH2, we can tribrominate those 3 positions. Well, the diazonium ion is going to get added through having an NH2 of an amine there. So once we have that, that amine can direct the 3 bromines into place. So let's pick up with our synthesis. The first thing we'll do, we need to get the nitrogen on the ring. So let's do a nitration. We'll put the nitro group right at the top of the ring. Next, we want to convert this nitro to an NH2. Let's use reducing conditions. This time, let's use tin and hydrochloric acid. Now we have our strong activating group, and if we just add bromine to this, an excess of bromine, we can tribrominate. So we'll brominate both ortho positions and the para position. Now we have our 3 bromines installed. We just need to get the fluorine in place. So first, let's convert the NH2 to a diazonium ion. We need NaNO2 and acid. HCl is a good choice. Still have our 3 bromines, but the NH2 is now this diazonium ion. And our counter ion, since we used HCl, is chloride. From here, to get to our final product, we just need to displace that diazonium ion with a fluoride, and the reagent for this is fluoroboric acid HBF4. And that completes this synthesis. For this next one, we want this trichlorobenzene. And one thing to keep in mind about this synthesis is we want to make it free of any other isomers. So we don't want to get contamination with both ortho-para isomers. We want just a single isomer produced in each step. And by using a little bit of strategy, with the aid of our diazonium ion reactions, we can do that. So what we need to do here, at least for strategy-wise, let's install a strong activating group at the top of the ring. From there, we want to install some sort of group that will block the para position. Then we can chlorinate. And if we have a strong activating group, we can chlorinate both positions, both ortho positions. And then our final steps will involve removing our blocking group and then converting this activating group via diazonium ion to a chlorine. Okay, well, let's just see how we can go about doing this synthetically. Well, the first thing we can do is start with benzene, and let's get an NH2 group on the ring. So in order to do that, first we need to nitrate. Then our second step will reduce that nitro group to an NH2. Let's use hydrogen and palladium on carbon. Okay, so we have this. Now, if we just added chlorine at this point, we would chlorinate both ortho and the para position. So what we need to do is install a blocking group at the para position. And that blocking group is actually going to be a nitro, which can be converted to a diazonium ion and then removed and just replaced with a hydrogen. But our issue here, if we want to do isomer free, how can we install something at this para position without getting something at the ortho positions? Well, what we need to do is convert this amine to an amide. We'll use acetic anhydride, and that will put this acyl group on the nitrogen. Now, this bulky group blocks out our ortho positions. So from there, we can put a nitro group selectively at the para position. So here's our nitration. Now, we can get rid of this bulky amide group by hydrolysis with acid and water. And that will just give us back the amine. From here, we can chlorinate. And since we have this deactivating nitro group on the ring, let's go ahead and add our catalyst to help us out to make sure we can chlorinate both positions. Alright, so from here, we have our NH2 that we can convert to a diazonium ion. Just write it as N2Cl. And now, if we want a chlorine, so if we look back at our starting material and our product, we want a chlorine at that top position. So let's use the diazonium ion and add copper chloride to convert that to a chlorine. So from here we have the three groups we want on the ring, but now we need to get rid of this nitro group which we used as a blocking group. So what we need to do is get this to a diazonium ion. So first we'll reduce the nitro to an NH2. From there we'll add NaNO2 and HCl. Now we have the diazonium ion. Now, in order to remove that, we can use the reagent H3PO2. And what this reagent does is it converts that diazonium ion to just a hydrogen, so essentially removing it. So we still have our 3 chlorines on the ring. Now this diazonium ion is converted to a hydrogen, and we're left with the 1,2,3 trichlorobenzene product, which is what we wanted. There's a number of practice problems available in the problem sets with these. If you want a few other molecules to try synthesizing, you can try making all of these from benzene isomer free, just for some additional practice. And you'll notice that when going through these, the strategy is similar in many of the cases. So you're frequently going to need to put in a blocking group at the para position, and then add your groups, and then remove that blocking group. That's a very common strategy. It's also common to use that bulky amide group if you need to block out the ortho positions. So those are just things you want to keep in mind or with your synthetic toolbox as you're working on these problems. So these are just some examples you can try. I'll put the solutions to these online so that you can check your work. And just be aware, there's often more than one correct way to get to the product. So even if your solution isn't exactly like mine, that doesn't mean it's incorrect.